enhancing applications in the cloud with messaging services. IBM Bluemix provides a highly scalable messaging infrastructure based upon Apache Kafka through the Message Hub service in the Bluemix catalog. In this video presentation, you will learn about how to use messaging to provide asynchronous communications between components in a cloud environment. After the presentation, you will understand common scenarios for use and available APIs for the Message Hub service, messaging terminology and models available for the different APIs in Message Hub in supported languages, how to use the worker offload pattern to make an application more responsive and scalable, and you will learn about delivery assurance and delivery model features of MQ-Lite. Let's begin with some terminology that's going to be used across the presentation. Messaging, our subject here, is a technology that enables high-speed, asynchronous program-to-program communication with reliable delivery between applications or components. A topic is a channel through which apps publish messages and applications can subscribe to messages. A queue is a channel through which apps pull messages that they want to receive by using a point-to-point model instead of automatically receiving every message on a particular topic. Only one application gets a message in a queue model. A sender, producer, or publisher is a program that sends a message by writing the message to a channel. A receiver, consumer, or subscriber is a program that receives a message by reading it from a channel. Point-to-point messaging uses queues. Each message comes from a source and is consumed by one application or service. Pub-sub or publish-subscribe uses topics. Messages that are published to a topic may be consumed by multiple subscribers. Speaking at a high level about trends in modernizing applications for a cloud application architecture, if we look at the architecture of a typical data center-based application, we see there is a front-end UI from HTML and client-side JavaScript, which scales because it runs within the client. Then, there is the back-end process that supplies it with the data which integrates into the enterprise and followed by a data tier. These applications are typically well componentized by a language in its runtime. Often they are developed by large teams and deployed into production by separate operations teams. If we look now at the architecture of some major cloud deployed applications, such as Facebook, Netflix, and LinkedIn, we'll see that these are often composed of smaller services. Each is owned by a small team of developers who are responsible for development and ops. These services are developed, tested, and deployed independently by these empowered teams. They tend to use different technology for both language and persistence. Why is this important? Because the links between these microservices are typically implemented using either REST or lightweight messaging, as we'll talk about in this presentation. IBM Message Hub for Bluemix is a scalable, distributed, high-throughput message bus to unite your on-premises and off-premises cloud technologies. Message Hub allows you to wire microservices together by using open protocols, connect stream data to analytics to realize powerful insights, and feed event data to multiple applications to react in real time. Message Hub is based on Apache Kafka, which is a fast, scalable, and durable real-time messaging engine. It's important to note that you're allowed to deploy only one instance of Message Hub in each Bluemix space. Let's go through some sample use cases for Message Hub and asynchronous messaging. One of the most obvious ones is achieving scalability through the worker offload type of pattern. This is the biggest and most obvious use case. Here, work that can be processed asynchronously is performed by separate processes, which can then be scaled independently. This makes a lot of sense for things like image and video processing, and also analytics. Then there's the event-driven model, where we avoid the inefficiencies of polling things all the time to see when they're done. For example, when a build is finished, then notify somebody. Or when the videos are finished transcoding, upload them. Then there's the case of delayed processing. You want to do this when you have things that need to happen at a specific point in time in the future. For example, you might want to wait to run reports until when the application usage is low. Messaging can also be used to improve responsiveness when dealing with third-party integrations. For example, you can ensure that things like send a tweet, post a new video, are queued so that even if a third-party service is unavailable at the moment, it'll be completed after it comes back. All of these use cases provide specific examples of decomposing an application to make it better. Currently, you can use 3 different interfaces to connect to Message Hub: the Kafka API, the Kafka REST API, and the MQ-Lite API. Message Hub's Kafka API is based on the Apache Kafka 0.10.2 and later releases, and is compatible with Kafka clients from release 0.9.0 and up. There are native Kafka clients for a wide range of programming languages. Why use the Kafka API? It offers lower latency and higher throughput than the other APIs, and it offers a richer API than the Kafka REST API. The Kafka REST API provides a RESTful interface to a Kafka cluster. You can easily produce and consume messages and complete administration tasks by using the API. Why would you want to use the Kafka REST API? The Kafka REST API is a convenient interface that can be used when a developer wants to quickly get started using Message Hub. But it really only makes sense when you're in certain low throughput use cases where latency is not a critical factor. Then there's the MQ-Lite API. The MQ-Lite API provides a simple yet powerful AMQP-based messaging interface for Java, Node.js, Python, and Ruby. The MQ-Lite API provides a higher level of abstraction than the Kafka API. MQ-Lite enables apps to be written quickly and portably in a unified messaging model that supports both queue and publish-subscribe messaging patterns, and use a hierarchical topic space and have simple controls for delivery assurance and message expiration. This allows you to implement scenarios such as worker offload, event notification, and batch processing pretty easily. To enable the MQ-Lite API, you need to create a topic with a single partition in Message Hub with the name MQ-Lite. For all of these APIs, you access the service using credentials that are stored in the vCap services environment variable. Let's look at a few scenarios. First, just the scenario of sending messages. We have a picture here of both the MQ-Lite and the Kafka API scenario. When we're talking about MQ-Lite, we refer to the application that creates the message as the sender application. And here, this application is sending a message to the topic space test/a. It's sending hello, and then it's sending world. And we also have a Kafka application that sends messages called a producer application. Kafka doesn't have a hierarchical space in the topic, so here we are sending to the topic test A the messages hello followed by world. Let's look at the receiving side. With MQ-Lite, an application that receives the message is called a receiver application. A receiver application attaches to something called the destination by providing a pattern. The pattern indicates the topics that they're interested in subscribing in. For Kafka, the receiving application is called a consumer application. In the Kafka example, the consumer application is attaching to a topic named test A. In both cases, the messages receive the application initiating app, hello, and world. Let's take a quick look at MQ-Lite API topic hierarchies and the use of wildcards. There's an example here in the slide of a topic hierarchy with 4 topics. MQ-Lite API supports a multi-level matching wildcard called the hash sign. The hash sign matches 0 or more levels. So, USA/hash would match all 4 of the topics shown above, and USA/Texas/hash would match the last 3. There's also a single level wildcard, which matches at one and only one topic level. So USA/plus matches USA/Texas only. USA/Texas/plus matches USA/Texas/Austin, and USA/Texas/Houston. The plus sign can also be used between slashes. For example, if we had a destination specified as USA/plus/Springfield, that would include topics USA/Illinois/Springfield, USA/Tennessee/Springfield, and USA/Oregon/Springfield. Let's look at some more examples of different connectivity scenarios with MQ-Lite and Kafka. Here's an example where we have multiple receiving or consuming applications. The key thing to note here is that in the top example with the MQ-Lite API, client number 1 is using the same pattern that we saw before to subscribe to the topic, test/A, and client 2 is using the multi-level wildcard, test/hash. In both cases, the clients receive the messages hello and world. In the second example, the Kafka applications both subscribe to the same topic name and also get the same messages. Message Hub has a model for persistence. In this example, the destinations for the messages persist for a defined period after the receiver detaches. The persistence is known as time to live in the MQ-Lite API and is known as log retention time in Kafka. Let's look a bit at the queuing model. For MQLite API, to implement queuing, clients attach using the same topic pattern and specify a shared destination. So here the application is sending hello and world, and one of the applications is receiving hello, and the other application is receiving the other message, world. To implement a queuing model with Kafka, you create a topic with multiple partitions. Again, the producer application is sending hello and world, and then the client applications or consumers connect using the same consumer group name, and they also connect to the same topic. So here in this scenario, producer application A sends hello and world, and the consumer applications each get a message. Let's look a little bit at the worker offload pattern using Message Hub. Message Hub can be used to improve the level of responsiveness that a user experiences when interacting with an application by offloading work from the application's main event loop. A key factor that determines the responsiveness of a web application is the amount of time that the web server takes to process an HTTP request and send a response. If a web server needs to perform CPU-intensive or high-latency processing before it can respond to a request, then the number of requests that the server can process is reduced. This can lead to a situation where the server can no longer keep up with the rate at which new requests arrive, and the web application becomes unusable. In the worker offload pattern, the web application submits the resource-intensive task to a queue. This queue is monitored by one or more applications that handle processing in the background. This allows the web application to more quickly respond and then update the view using an asynchronous model when the worker completes. An application component implementing the worker offload pattern through messaging services should not be configured with an application route in an environment like IBM Bluemix Cloud Foundry applications. To avoid this, you may use the bxapp push command with the -- no route option to prevent the Cloud Foundry environment from creating a route on application startup. In MQLite, the lifetime of messages and destinations is controlled by the time to live, TTL, which refers to the time in milliseconds that is applied to both the message and the destination that the client is subscribed to. The level of message delivery assurance is handled by the quality of service, the amount of processing that occurs to ensure that a message is transferred between the client and the server. MQLite supports two qualities of service. At most once message delivery. A message will usually be transferred once. However, situations can occur when a message will never reach a recipient. Messages are never transferred more than once, meaning they aren't duplicated. Or at least once message delivery. A message will usually be transferred once. However, situations can occur when a message is transferred or duplicated more than once. At least one copy of a message will always be transferred to a recipient. Each time a message is sent from the client to the MQLite server or received by the client from the MQLite server, it is transported by using one of these two qualities of service. You can specify the quality of service to use in the client send method call or the client subscribe method call. If you do not specify a quality of service, then you will get the default quality of service, which is at most once. This concludes our overview of messaging in the cloud using IBM Message Hub. Thanks for listening.